Welcome to The Explainer. You know that device you're watching this on right now? Your phone, your laptop? They kind of feel like magic, right? Well, today we're going to pull back the curtain and see how they actually work.
So let's get right into it. We use these things every single day, but have you ever stopped to think about the real mystery here? How does this box of metal and silicon, actually think? How does it all come together to do what we tell it to do?
You know, they say the best way to really get something is to build it yourself. So that's exactly what we're going to do. Right here, right now. We're going to build a computer from the ground up, piece by piece, just to see how it ticks.
All right, first things first. Every thinking machine needs a body, right? The physical parts. We call that the hardware, and we're going to start with the most important bits, the brain and the memory.
Okay, the absolute first thing we need is a brain. And in a computer, that's the central processing unit, or as you've probably heard, the CPU. This is the powerhouse, the engine that does all the heavy lifting, all the math, all the logic, basically all the thinking.
Well, a brain can't just float in a void. It needs a workspace, like a desk or a scratch pad to jot things down on. That's where random access memory, or RAM, comes in. Think of it as a super fast, but temporary, holding area for everything the CPU is working on right this second.
Okay, so RAM is great for what's happening now. But what about all your stuff? Your files, your photos, your programs? What happens when you turn the computer off? For that, we need long-term memory. And we just call that storage. This is the permanent home for all your data, where it lives safely until you decide to get rid of it.
So this is a really important difference to get. Just think of it like this. RAM is your desk. It's super fast, everything's right there when you need it. But at the end of the day, you clear it off, right? Storage, on the other hand, that's your filing cabinet. It might be a little slower to find things, but everything is stored there safely for the long haul.
Okay, so what have we got so far? Basically, a brain in a box. It can think, but it can't see, it can't hear, it can't talk. It has no way to interact with the world. Let's fix that. First up, let's give it some senses. In the computer world, we call these input devices. This is how we give information to the computer. Every time you type on a keyboard or click a mouse or tap on a screen, you're basically telling the computer what you want it to do. And, of course, it's not a one-way street. Our machine needs a way to talk back to us, so we give it a voice and a face using output devices. The monitor you're looking at, the speakers you're hearing my voice from, even a printer. That's all the computer communicating its results back out into the world.
All right, let's take stock. We've got a body, a brain, and senses. The hardware is all there. But right now, it's just a really complicated sculpture. It's got all this potential, but it has absolutely no idea what to do.
And this is where the real magic comes in. That hardware is totally useless on its own. It needs instructions. It needs someone to tell it what to do. And that is software. It's like the ghost in the machine, the digital soul that actually makes all those physical parts come alive. A good way to picture this whole thing is in layers. So at the very bottom, you've got the physical hardware we just put together. Then, sitting right on top of that is the most important software, which acts like a bridge, letting other programs and you, the user at the very top, talk to the hardware. So that core layer of software, that's the operating system, or OS. This is the big boss. It's the first program that wakes up when you turn the computer on. It manages everything, the memory, the CPU, all the inputs and outputs. Honestly, without an OS, like Windows or Mac OS or Android, your computer is just a really, really expensive paperweight.
And then, finally, sitting on top of the OS, you have your applications, or apps, as we all call them. These are the programs that do specific things for you. Think of them like special skills our computer can learn. Your web browser, your photo editor, your favorite game, they're all applications that use the OS to talk to the hardware and get the job done.
So there you have it. We've built a basic computer. It's got hardware, it's got an operating system, it's got apps. But, this beautiful, elegant design didn't just pop out of nowhere. Let's take a super quick trip back in time to see how we got from clunky mechanical gears to this.
This journey really started thousands of years ago with simple things like the abacus. But the big idea, a machine you could actually program, that came about in the 1800s. The real game changer, though, the transistor. 1947. This tiny little switch let us shrink computers from the size of a room down to something that could fit on a desk. And that led directly to the microprocessor, an entire CPU on one single tiny chip.
And the engine behind this incredible shrinking act was predicted perfectly way back in 1965 by Gordon Moore, one of the founders of Intel.
He saw that the number of transistors we could cram onto a chip would basically double every 2 years. That idea became known as Moore's Law, and it's been the driving force of tech ever since.
And that relentless doubling, that exponential growth, that's the reason the smartphone in your pocket is literally millions of times more powerful than the massive computers that sent the Apollo missions to the moon. It's just a staggering pace of progress, and it has totally changed our world.
So here's the thing to remember. Those basic building blocks we just put together, the CPU, memory, inputs, outputs, software, they are still the heart of every single computer today. And as they get smaller and more powerful, they're setting the stage for the next incredible wave, things like AI and the Internet of Things. Which, leaves us with a